When we look at bonding of nonmetals, remember, when we talk about nonmetals, those are the ones over here, and metals, everything else except hydrogen. The nonmetals can bond together all by themselves. And that's a little bit different than what we spoke of before. And there we have slightly different rules to figure out how things pair up. And we can go into that in a separate lesson as to why the rules exist. But I'm just going to tell you, everything in this row wants one bond. All the halogens want one bond. Here, they want two bonds. Here, they want 3 bonds. And here, they want 4 bonds. And again, there are exceptions to those rules, but carbon generally wants 4 bonds, nitrogen wants 3 bonds, oxygen wants 2 bonds, fluorine wants 1 bond. With that, fluorine has 3 lone pairs. I'm just going to abbreviate that, 3 lone pairs. The oxygen row, oxygen and sulfur, for example, want 2 lone pairs. Nitrogen wants 1 lone pair. And carbon does not want any lone pairs. And the other thing, the thing to notice there is that the numbers add up to 4. 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 is 4. 4 plus 0 is 4. So if we just kind of remember those rules and we look at oxygen, like why is oxygen gas written as a diatomic? It's diatomic, that's what that 2 means. It's because oxygen is actually 2 oxygens stuck together. If we could zoom in on oxygen, and it's because oxygen wants 2 bonds, and then, of course, it's got to add up to 4, so it has 2 lone pairs. And so we can draw that as oxygen with 2 bonds and 2 lone pairs. It turns out hydrogen, there's this funny thing where we put hydrogen over here, and I talked about that in a previous video because like lithium, it would also like a 1+ charge at times. There's other reason to want to put hydrogen right here, and that's because it also wants 1 bond. And you could think about trying to put hydrogen there, and I think there's legitimate arguments for both. It's traditionally put over here, but hydrogen, this outlier all the way over here, hydrogen wants 1 bond. And then it also has this silly thing where it's unlike these and it has 0 lone pairs. So it's an exception out there. And with these silly rules, we can start talking about what the structure of methane gas is. Methane is the gas that we use in our houses. It comes in on pipes. Natural gas, it is often called. It is a gas. But carbon wants 4 bonds. Hydrogen wants 1 bond. Carbon doesn't want any lone pairs. And hydrogen doesn't want any lone pairs. And if we're going to draw it on a sheet of paper, we can talk about the 3-dimensional structure later. But we can draw it on a piece of paper, and there's nothing wrong with that drawing. And so that can be methane gas. And you can keep doing this. Nitrogen wants 3 bonds. Nitrogen's a diatomic. Nitrogen has 1 lone pair. And so you can draw nitrogen with 3 bonds and 1 lone pair. And that would be nitrogen gas, which makes up 70% of the atmosphere. It's all around us. If somehow you could zoom in on that gas and look at a nitrogen molecule in the air, it would really be 2 nitrogen atoms stuck together. Triple bond is as high as we can go. You cannot have this. It would seem like you can. Carbon wants 4 bonds. This is a no-go. A triple bond is the highest that we go to. You know, we can talk about like water. Water is a great example. H2O. It can obviously be a liquid, a solid, or a gas, and it's a fun molecule. It's actually one of my favorite molecules because it seems so simple, and in fact, it's quite complicated. But nonetheless, the simplest drawing of water is just hydrogen stuck to an oxygen. Water really is in a bent conformation. I think it's about 104 degrees between them, but I can't remember, 104, 109. And then there's 2 lone pairs on the oxygen. And so this satisfies all the rules. Hydrogen likes to have 1 bond. Here, each hydrogen has 1 bond. Oxygen likes to have 2 bonds. It's bound to 2 different hydrogens, but that counts as 2 bonds for that oxygen. And the oxygen has its 2 lone pairs. And so this is the example of non-metal bonding. Or more commonly called covalent bonding. And of course, if you want to get more into that and understand why this kind of comes and get more of a narrative, you can study Lewis structures. And Lewis structures are a commonsensical way of drawing, and that's actually what these are.